Welcome back to part 2 of the two-part discussion of kinematics and deriving the kinematic equations for a constant acceleration in one dimension using only algebra. So in the first part, we talked about how there are 5 components to the kinematic equations, 5 quantities we can know: displacement, initial velocity, final velocity, acceleration, and the amount of time that's elapsed. And each family of kinematic equations we can deal with involves 4 of those 5. So that means we need to find 3 knowns to be able to solve for the other 2. So as I said, 5/3, 5 knowns, 5 possible knowns, 3 definite knowns, and then once you have your 2 unknowns, which one are you looking for? Which one do you not need? So sorted by the 2 that we talked about, 2 equations based on items that we don't have and don't need to have. If we don't need displacement, we have the definition of acceleration, which one of the 4 ways it can be written: final velocity is initial velocity plus acceleration times time. And if we don't know anything about acceleration, from the definition of displacement, that displacement is our average velocity times time, our displacement would be 1/2 of the initial velocity plus the final velocity, and then that quantity gets multiplied by our change in time. So, to figure out the other 3 families of equations, we can take equation 1 and equation 2 and combine them together. Specifically, I'm going to take equation 1 and substitute it directly into equation 2 first. So, that means my displacement would be 1/2 times my initial velocity plus the quantity of my initial velocity plus acceleration times time, and then that quantity gets multiplied by my change in time. Well, v initial plus v initial gives me 2v initial plus acceleration times time, and then that quantity gets multiplied by time and by 1/2. So 2 times 1/2 means my displacement would be my initial velocity times time plus 1/2 times my acceleration times time squared. So again, our textbook calls this the primary displacement equation. It's not primary at all. It's just, this is the displacement equation when we don't know v final. It's like we're projecting our motion based on how we start at the beginning and then adding in the effects of the change that we know about as we move forward. Well, I could have just as easily substituted in what v initial would be. And for v final equals v initial plus at, v initial then would just have to be v final minus acceleration times time. And my displacement then, without v initial, would be 1/2 times v final minus acceleration times time plus v final times my change in time. Well, that would give me 2v final over 2, so I get my displacement is my final velocity times time minus 1/2 times acceleration times time squared. So this is the displacement equation when we don't know our initial velocity, but we do know our final velocity. So we project how far we've gone based on how we're traveling at the end, and then subtract off the effects of the changes. All of these equations, all the same equation, it's just a different set of 3 knowns that we're dealing with, and in each one there's an unknown we don't need. Don't need displacement, don't need acceleration, don't need final velocity, don't need initial velocity. So that means we should also be able to do it without the time. So if I instead solve my acceleration equation, the definition for time, I would have v final minus v initial over time is acceleration, or time is v final minus v initial divided by acceleration. So if my displacement is 1/2 times v initial plus v final times time, I'm just going to flip v final and v initial, adding commutes. totally cool. Can just flip the order. So when I fill in for time, that gives me, instead of v final plus v initial, v final minus v initial. And if I have a plus b times the quantity a minus b, that gives me a squared minus b squared. So in my numerator, I have v final squared minus v initial squared. And 1/2 times 1 over a means I'd be dividing by 2 times the acceleration. So if I don't know anything about time, without time, my displacement is v final squared minus v initial squared divided by 2 times the acceleration. And again, this just represents 5 ways that I can write the equation of motion. We can take each one of those 5 families, no displacement, no acceleration, no v initial, no v final, and no time, and rewrite each of those equations for total times so that we could take any 3 knowns and then immediately be able to identify what would be the proper solved form of the equation. So 20 calculations in the very beginning when you'll never have to do any math again. Seems like a pretty good trade-off, and it can help sharpen up some of those algebra skills too as we start getting into this course. Thanks for watching.